Hello, welcome to module 10, part 3. This is we're going to be covering Planck's constant. So to begin, we're going to talk about E equals hv, h being Planck's constant, which is 6.63 times 10 to the negative 34th joules times second. Remember, this VU looking shape is frequency, and E is like the energy. So just it's important to note that. So I'm going to be doing an example problem, to cover this concept. So calculate the energy of an electromagnetic wavelength of 2.3 times 10 to the 10th nanometers. Okay, so they're going to give us a wavelength, which is lambda, which is 2.30 times 10 to the 10th nanometers. Then they want us to calculate for energy, like right here. We don't know that. And then you'll see that for E equals hv, we're going to need frequency, but they don't give us it. So we're going to have to solve for that as well. So they give us wavelength. And we're trying to find a frequency. So that means we're going to have to use constant speed of light, which is 3.00 times 10 to the 8th meters per second. So yeah. And then finally, we're going to also use a Planck's constant as well, which is, as mentioned, 6.63 times 10 to the negative 34th joules times seconds. So, as we talked about the last video, speed of light is in meters per second, but our wavelength value is in nanometers. So what we're going to have to do is we're going to have to convert. So for this explanation, I'm just going to convert just to begin with all the math process. So yeah, 2.30 times 10 to the 10th nanometer. Then we have for 1 nanometer, you'll get 1 times 10 to the negative 9 meter, because nanometers is smaller and we're moving to a bigger unit. So we're going to get a smaller number. So once we do that, we're going to get approximately 23.0 meters. So then we're going to use, E equals hv. And then we're going to substitute v for this. Because remember, we're going to rearrange the equation to solve for v. So it's going to be constant speed of light divided by wavelength is going to give us frequency. So we're going to substitute v for this. So then we should have everything to solve this problem, and so then we should just plug in the values now. So we have 6.63 times 10 to the negative 34 joules times second, and then we plug in our values. So we have 3.00 times 10 to the 8th meters per second divided by 23 meters as we converted earlier. And then once we calculate this on a calculator, we'll see that we'll get a value of 8.65 times 10 to negative 27 joules. So then E is going to equal to 8.65 times 10 to negative 27 joules. So that will be the answer to our problem. So remember, we're gonna Planck's constant is h in the value, and the number is 6.63 times 10 to the negative 34th. So, and then when we approached the problem, we wrote what we knew and what we didn't know, and then we converted from nanometers to meters, and then we pretty much solved for V in this rearrangement of the formula, and then we just applied the, this portion over here to help us solve for energy, which turned out to be our answer. So yeah, I hope this video helped, and have a good one.